So now we're going to set the colors of the vertex based on their associations with other tweets, and we're going to set the labels of the isolated vertices, the ones that were around the perimeter, to the IDs, to their tweet IDs, and the first 20 characters of every tweet. So the ones on the outside will have text, so we can see what they are, and the ones in the middle that are have a large number of associations, a high degree, will just have their numbers. And we will also set the color and width of the edges based on their weights. And it takes a second for this to show up. Okay, but we have we have to load in the library of the tweets so that we can associate the actual text with these numbers. And to do that, we have to load in Twitter R. We have to load in the library to manipulate it, and then we have to load in the object that has the actual text of the tweets, which is also an object in your folder, rdmtweets.rdata. So we come down here and grab that. And we're going to convert the tweets into a data frame and then take a look at it. So the tweets themselves are these. So they're the actual tweets, the text. And so now we're going to append the we're going to set the labels to the IDs and append or paste the first 20 characters of the tweets to them. And let's see what it looks like so far. This is not the finished plot. Okay, so now you get an idea. For the ones that are isolated, that don't share terms, and it takes a second to produce, these, we have the actual text, first 20 characters of the tweet appended to the number. These are tweets that have a lot of associations with the other tweets in terms of the words that are in them. And so we don't append the text to them because it would be too messy. Okay, and so then finally we're going to run the plot again using this Fruchterman-Reingold layout. And it takes a while. The zoom is actually there we go. Okay, so these are all isolated, and there, you notice this little subgroup up here, or cluster, if you will. The ones in the crescent are isolated, so we're going to get rid of them using delete vertices. They have a degree of 0. This will just pull them out. We'll delete them. We'll run the plot again. And it takes a second. And here's that little cluster again, or click, if you will, of tweets that are connected on the periphery. In order to make this more readable, we'll get rid of edges that have low degrees to simplify it. And that is, we'll get rid of edges that have a weight of 1. And that will also cause more vertices, more of the tweets to become isolated, so we'll get rid of them. We're trying to trim it down so we can see what's left. And we run the plot. And let's zoom it. Here's a cluster here, or a click. We're going to take a look at this one. And so we can actually, we are actually printing out the text in each one of these from our data frame that has each individual tweet in it. So we can see what they have in common. And this just lists them in order. It's easier to do it like this. So now we can see the actual nature of these tweets in the order in which they occur. And if you read through this, just do a couple of them. Tweets 7, 12, 6, 9, 8, 3, and 4, which were close to each other and connected, have something to do with parallel computing. 7's parallel computing, 6 parallel computing, 4 parallel computing. Tweets four, 5, 154, and 71 have something to do with our package. Well, we don't have that here. We just had the click. So we're looking at one click. If you followed up with all these other ones, you would find the reason for their associations. Let's try one more. This is a two-mode network. Here we're going to look at vertices that we have vertices that are tweets and vertices that are terms. So we'll start by creating a graph from term.matrix, and we'll use different colors and sizes to visually separate the term vertices from the tweet vertices. Okay, so here's our graph. And it's pretty busy. You have both tweets and terms. You can see the words in there. So we'll get the indices from the term vertices and the tweet vertices, and we will set the color and size for them differently. And here we're setting colors and sizes. And then the edge width and the color. And then we're going to run the plot. It takes a second. So you can see now which terms occur most often. It appears as if most of the tweets are clustered about the terms data mining and, or actually mining and data. Those two terms are the separate vertices, but they're very close to each other, and they have a very large number of connections with the other tweets. And you also see the letter or word R is associated with a very large number, has a high degree of association with many of the other tweets. And all the numbered, which are red, are the tweets, and the green ones, which are labeled with text are terms, and so we have those two centers, R and data mining. Data and mining were so close together that they looked like they were one vertex, but there's actually two. And so here we're going to return all the vertices which are neighbors of the word R. And it's thinking, and there they are. So these are tweets that are associated, have the term R in them, very large number. You can also accomplish the same thing using the neighborhood function. And so finally, we'll have a look at the tweets that have all three terms, R, data, and mining. And it's these.